The Hubble telescope has revolutionized the observation of space. If the satellite masses 11,110 kg and orbits at 552 kilometers, how much force does Earth pull on it? Well, once again, I've given you a distance, but I've given it to you in the wrong units. So you have a distance and you have 552 kilometers, but I know that every 1 kilometer is 1,000 meters, and I'm pretty sure if I do the math, I get 552,000 meters. The mass of Hubble, it tells me, is 11,110 kilograms, which is the units that I wanted in, but I also need to know the mass of Earth. And here's the well, it's not a problem, it just means I need to go back to my grid and say that, okay, Earth masses 5,973 times 10 to the 24th kilograms. Okay, that's the information I need. I know that G equals 6.673 times 10 to the negative 11th, and I'm looking for a force again due to gravity, and that's going to be in newtons. Mass 1 times mass 2 over distance squared. Alright, so I don't know what the force due to gravity is, but I do know that G is 6.673 times 10 to the negative 11 times the mass of the Hubble telescope is 11,110 times the mass of Earth is 5,973 times 10 to the 24, which is a huge mass, divided by the distance in meters, which is 552,000, but I have to square that. So if I solve the top of the parenthesis, 6.673 times 10 to the negative 11, 11,110 times 5,973e 24, I get 6.636003 times 10 to the 31. But I'm going to divide that by 552,000 squared 3.04704 times 10 to the 11. Now if I solve the parentheses, 6.673 times 10 to the negative 11, 6.63603 E 31 divided by 3.04704 E 11. I get times 2.1778 52276 times 10 to the 20. And then if I multiply that by 6.673 E negative 11, I get a force due to gravity equals 1.45328084 times 10 to the 10th newtons. And then if I make that pretty in Mr. Fay's class, that's 1.45 times 10 to the 10 newtons, or I can write it 1.45 E 10 newtons. I would accept either one of those answers.